Hello and welcome to this AWS reInvent presentation on Amazon.com's reducing time to market and TCO using serverless technologies. I'm Rudy Chetty, a solutions architect with AWS, and I'm joined by Jen Lin, a principal engineer with Amazon.com. So let's get into it, shall we? First up is the agenda. And what is serverless? That's what we're going to understand before we dive into it. Then we'll bring Jen up to talk about the STEM Club toy subscription with the components, results, and then we'll have some closing arguments. So what is serverless? First, to kind of understand what is serverless, we're going to understand what is server-based computing. In this case, you have capacity that you need, so you buy servers. You could buy 1, 2, you could even buy hard drives. From there, you can double your capacity, but it kind of gets you to the stage where you're going to have a server farm that might try to kill you. So we kind of go to the serverless way of doing things, which is a bit more simpler. So the server-based approach is unmanaged, where you have to go in and manage all these servers yourself, whether it's patching, OS updates, adding more hard drive capacity, and so forth. Whereas with serverless approach, you actually use a managed service. So you could say, hey, AWS, give me X compute capacity, or Y database space, or even storage space on the Z spectrum here. Now, there's several serverless services at AWS. The first one being AWS Lambda. There's also AWS IoT Core, where you can send all your IoT data and have it stored in AWS IoT Core or put into different services in AWS. You have Amazon SageMaker, which is our machine learning offering, and from there you can create machine learning models and run them in the cloud or even on the edge. We have Amazon DynamoDB, which is our NoSQL database offering, Amazon API Gateway, and even AWS Fargate, our managed container offering. We have a lot more services, but let's kind of concentrate on these three here. So the first one that's up is AWS Lambda. Now, these are stateless functions that you write once and run multiple times. They can be in any language. So we have ones that are supported natively, like Java, Node.js, and we have custom runtimes that you can include in your Lambda functions, which allow you to run any other language technically. They can be run in an asynchronous or synchronous fashion, so you can run them and let them go, or you can wait on them in a synchronous fashion. We also have VPC support, so virtual private cloud. You can run them in your own VPC and therefore limit the blast radius for anyone trying to access these functions. We have service integration, so you can contact any other AWS service or push the data to it. And for mechanisms of retry and failover, we have something called a DL queue or dead letter queue. You can even debug these functions using AWS X-Ray, and that's where the support comes in here. You can run these functions for a maximum of 15 minutes, and the maximum memory allocation is 3 gigabytes. We also have environment variables, so you don't have to hard code or store your, let's say, proprietary or sensitive information in the functions themselves. So that's AWS Lambda. The next one is Amazon DynamoDB. Now, as I mentioned, this is our NoSQL offering. It is a key value store. So you give it a key and you can retrieve a value. It allows you to access data in a single digit millisecond. That's pretty fast. We have on-demand offerings or provisioned, so you can spin up an Amazon DynamoDB database and have it run in an on-demand mode, which means that it'll scale up and down depending on your need. Or provisioned, where you're going to say, you know what, I have a stable kind of database need, and I want to provision it at that particular time for that particular capacity. You also have adaptive capacity, which what it does is it learns what your database is doing at that particular time, and it adapts accordingly. We also have global tables, and what that means is you can provision tables globally. You don't have to have them in one region. You can have them in multiple regions all at once. And DAX. How could I forget about DAX? Or DynamoDB Accelerator. That allows you to put a write-through cache in front of Amazon DynamoDB, which lowers your response time to sub-millisecond, which is even faster. And the last one, in fact, before we go on to the next slide, this is an example of how you would select data out of your table, or a table called I say table, called Music, and where the artist is no one you know, apparently, and the song title is Call Me Today. We're not going to be putting my phone number up today, but stay tuned for more. So API Gateway, that's the next one. It is a RESTful API service that we have in AWS, and that allows you to provision anything in the backend or expose underlying functionality as a RESTful API, which means that you can perform gets, puts, deletes, and so forth. You can connect to any number of AWS services, your NLBs, Lambda, and so forth. And you can have authorization built right in. So that's out of the box, you get it, where you can authorize only trusted users, trusted services to connect through API Gateway. We also allow third-party keys, so you can provision them for third parties that are accessing your API Gateway gateways. And from there, you can say, okay, well, this particular user or party, I'm going to let them only have a certain amount of capacity or a certain amount of calls, and that's what you can use to do that. You can use these keys. You can also throttle. So as you know, Lambda has a maximum concurrent duration or limit for the duration executions, and that is 1,000. And you want to limit all the functions that are going through API Gateway such that they don't overwhelm your Lambda capacity. So that's where the throttling comes in. But the last thing to mention here is monitoring. And what would a service be without monitoring? And in this case, you're going to have CloudWatch integration where you can monitor anything that's going on in your API Gateway. But you know what? That's all fun and games. It's time to bring up our customer, Jen Lin, from Amazon.com to talk about the STEM Toy Club subscription service. So stay tuned and you'll see her just now.
Thanks so much, Rudy. That's such a great introduction to the services and the offerings that are available from AWS. And I'm a big fan of you and just your different offerings. This is great. I'm going to talk to you today about how Amazon.com looked at opportunities to reduce time to market, get something out quickly, and reduce the total cost of ownership using serverless. And we're going to focus this case study on the STEM Club toy subscription. STEM stands for Science, Technology, Engineering, and Math. And what we were seeing is that parents kept writing to Amazon asking for an easier way to discover educational toys that were good, that were any good for educating their children, and especially in the science, technology, engineering, math, or STEM fields. They kept finding that the marketing did not always match the product. So we looked at this problem space and we said, what opportunity do we have to curate a set of really high quality toys that would bring kids educational content that is so fun that they wouldn't even notice that they were learning? And that's what really motivated us to go into this space and consider what could we do to curate this list and build what we called STEM Club. All right. And there are cases where the customer has a membership to a program, and it should provide a variety of benefits. So when we're thinking about STEM Club's goals, we weren't just thinking about how do we get a curated set of toys. We're also looking at how do we ship some physical items? How do we give access to digital content? And maybe even provide things like an item discount. For example, we provide free shipping for these toys, and that would be a discount on these items. So we're kind of looking holistically at what we could do with this membership program. And the benefits that we're providing in these subscriptions, they may not always be the same. We may know that your child already has purchased a given educational toy. Maybe you purchased it last year, and we don't want to send you something that we know you already have. We also want to be time dependent. So we might want to say that this is an item that's really good for May. This is another item that's great for June, and kind of have that sequentially delivered. We also may want to be order specific. So we might want to be able to say, do box C before you do box D. And we also were thinking about this subscription model and thinking, how do we make it so it could be either one time, just one instance, or an ongoing cadence? When we do work at Amazon.com, we always work backwards from the customer. So we put the customer first. And when we scoped out the project, we said we want to take the customer and we want to map them to a membership with benefits. We want to validate that the customer has not already gotten the benefit, because we don't want to be shipping you something we know you already have. And this project isn't actually managing the fulfillment systems, because obviously one thing that Amazon.com is famous for is the logistics of getting a package to your house fast. What we determined was we could do the selection piece, decide what benefit to send to the customer, but then pass that along to the fulfillment system in an orchestration manner. And I also want to go through some quick terminology so that way I have a shared understanding of some of the terms. Customer, in this case, is an Amazon customer, and we have an ID for them. A subscription is a product that you purchase that lets them have some benefits. And at the end of each period of the subscription, they will receive those benefits either physically in the mail or in a digital form. And a benefit is the item that the customer receives. So again, that physical or digital product. And the plan is how we're managing these subscription mappings from the customer membership to the benefit. And having all this scope, understanding this work backwards process from what customers need, I pitched to my executive team. I think we could do this with a total of 3 engineers. And I think we could do this pretty cheaply and be able to deliver results for our customers without a huge engineering build. So we hired up the team and we basically asked them, how would you like to build this? The first place the team looked was at the data model. So how do you store the plan, as I said, that manages this kind of membership information, and map that to a set of benefits? Those benefits are things that we're going to vend for their subscription. And the team wanted to put in front of this data model some APIs. You can imagine the most important ones are to be able to get the benefit items and to be able to add the benefit items. Basically, if you think of CRUD operations, the create, read, update, and delete, essentially we needed to make sure we had those APIs in place. And we wanted, as an engineering team, to understand our priorities. And we actually went through and listed them out. We need to be able to create a subscription, top priority. We need to basically make sure that we have this data that is then created in our database. We need to collect enough information to be able to place the physical orders. So we might need to know where to ship it. We might need to know how to charge the customer. And we want to make sure we're using a scalable, reliable solution. Availability is a really key concept when you look at Amazon.com. We can't provide customers a solution that doesn't work day to day. We need to make sure that we have something that's not only going to scale to our needs, but also be reliable. Finally, when we went through and built our design, we wanted to understand the assumptions. So we assumed we will use a subscription platform to manage state. We assumed that the items will have the following attributes. All items sold in the subscription have a product. The product may have other offers or opportunities to be purchased by customers, but the subscription price will always be lower than the retail offer price. We didn't want customers to ever feel they weren't getting a good deal. And all products in the program have to have a relationship with the vendor that is selling the item to make sure that they are program eligible. Another key thing that you just have to talk through as an engineering team is scale. What are you expecting as far as scale? We had 3 engineers. We had about 5 months to build the solution. And in that year that we were starting the program, we were planning to get at least 5,000 subscribers by the end of year 1. Fortunately, we were very lucky. We actually doubled that in the first year. So we ended up, more than being successful. In the end of year 2, at least 20,000 subscribers. TPS for the purchase workflow is relatively small. Let's call it under 100 TPS. So we knew that we're not going to be a really high throughput system the way something like a DynamoDB system would have to scale to. But we knew that when people were looking at the detail page, because of the way that, maybe a news article could go out, many people would be looking at the detail page that describes this STEM club. And we knew that could be much higher. So we needed to be ready to handle more than 500 TPS for that component. So the team has been gathered. We got the team hired up. We all agreed on our design constraints, our high-level architecture. And the next thing we had to do was to go through and build it. what we decided on doing was what we call a nano service implementation. Now, it's a pretty common term in the industry to talk about microservices. Those are services that have a very constrained domain. A nano service is a microservice that's even better. It's a microservice that is hosted, it is deployed, it is reusable, and it's orchestratable. These are really key components to the nano service solution. The hosted component means that you're not managing the service on hosts. So this is thinking back to the introduction where we talked about managed versus unmanaged. This is going to be a managed solution. It's going to be deployed, and in fact, we were using continuous deployment. This reduces the cost to get changes to the production instance. Reusable. We don't want to build something just for STEM Club. Frankly, Amazon's a very frugal company. Amazon.com has a frugal approach. Whatever we build, we need to be able to reuse over and over. And finally, it has to be orchestratable. It has to be something that can take a domain, take action on it, and be able to be orchestrated across other components. In this case, we determine what the benefits are, and I mentioned we would then hand it off to the fulfillment systems. So we orchestrated that handoff between selecting the membership benefits and then handing it off to the fulfillment systems that get the box to your home. Let's look at each of the components we use to build the solution that I described, this nano service solution. And again, calling back to Rudy's slides, we're going to use some pretty familiar constructs. So Amazon API Gateway, this is going to be our front door to the solution. AWS Lambda is going to be our compute component. And all of the state and data that we need for the system will be stored in DynamoDB. Finally, we did use Amazon S3 as well, mostly for logging and auditability. Let's talk about why we chose each of these components. API Gateway lets us define our interface. It allows us to provide API keys. These are the third-party keys that we heard about, where you can do authentication between different services and different client IDs. We also used authorization to make sure that the data that's being accessed is authorized for the service and the user. It also allows us to configure a domain name and have usage plans so we can do things like throttling. Behind the API Gateway, we have AWS Lambda. Lambda we chose because it allowed us to power the generic CRUD operations, again, create, read, update, delete. It allows us to respond to the API Gateway inputs and also respond to database changes as well with our Lambda. It generates an auditable record of objects that we're creating, and it executes code. And fortunately for us, because we're such a small team, 3 people, we didn't want to have to manage a fleet. I like to joke I am a very lazy principal engineer. I don't want to have to do fleet management, and so this allowed us to hand that off to the AWS Lambda system. Finally, DynamoDB. This is where we're storing our data. It allows us to put all of the state into the database. It enforces uniqueness, it enforces authorization, and provides access logs and metrics. And what we were doing when we were storing these access logs, this metric data, and also our DynamoDB backups, those are all going to S3. So that's kind of the stateful piece of our component. I like this comparison when I look at serverless and servered, or managed versus unmanaged solutions. The first thing we did as a team was we built a prototype of what would be required. We built it in Ruby on Rails. And Ruby on Rails is a pretty succinct language. It's not very verbose. We still saw we had 400 lines of Ruby to do what we needed done. In this serverless implementation, we could do it in 40 lines of Python. Literally 1/10 of the code for the same implementation, the same functionality. That's a huge win. And I like to share the initial Python because you can put it on one slide. So I said that eventually we had 40 lines of code. We actually started off with more like 10. It was a really impressively succinct opportunity to not have a lot of code to manage, but still get the business results that we needed. And I wanted to give you a sample call so that you understand how we're calling our API Gateway. So basically, we would pass a GET request to API Gateway that would look like this. And maybe we wanted to be able to do a filtered read. So this is looking at the data that is available to the client that's calling the API gateway, and they want to filter based on membership ID. So that's what we're doing here. And it was something we were able to put together, the first iteration of STEM Club, in a week. We were able to spin up the Lambda, the API gateway, DynamoDB in a week as a team of 3. We're not talking months here. It was a really blazing fast operation to get things up and running. We also did some simple testing. So here's an example test case that we might add to our database. Let's start to talk about the results. So when you call the API, the results look like this. Pretty basic mapping of business ID, manage the membership information to the benefit list. And I want to talk about the advantages of having this pattern, this Nano service pattern, where we are not managing our own hosts and we're not building a full service. The data is properly isolated and encapsulated. This is really key to having a correct architecture. You want to understand your data domain and isolate appropriately. This pattern of using API Gateway, the Lambda, and DynamoDB supports a Nano service architecture. It has all the requirements around being hosted, orchestratable, and correctly designed. It's easier to onboard than other alternatives. There just weren't that many steps. Lambda has nearly instantaneous deployment of changes. Our continuous deployment pipeline was incredibly simple. And the cost of the hardware, the cost of operations was very low. My executives absolutely loved this program because our bill every month was just not that high. Let's talk specifically about the cost of operations, because developer ops or DevOps can be a large cost that is not always planned upfront. So this is a system that's run by a team with 3 developers. We're not talking a huge team. Each day, this system, as it stands today, responds to event counts that are in the millions. So we're having fairly decent throughput at this point. The system supports dozens of subscription products. Like I said, we had to build something reusable. We started with STEM Club, but we're able to expand to a whole industry worth of different subscriptions. Very few code changes. When we look at the deltas in the code, they tend to be about adding functionality, making it more sophisticated, not about keeping up with patches or dealing with operating system upgrades. We're really just looking at what does this code need to do. And we haven't had any downtime in over a year. The system is just self-maintaining, very much so. And this is looking at the number of events that we're seeing over time. It's all up and to the right. It's been very positive reaction from customers, and the system has had really no blips. In closing, I just want to sum up, if you look at the incredible results we were able to see and the frugal approach to getting there. Now we've grown. We're not just talking about educational toys. We're not just talking about a STEM Club subscription. We're looking at dozens of subscriptions that are powered by this system. And even if you zoom in and look at just the subscriptions for your pets, we've got a bunch of those. We're able to do quite a bit for subscription boxes on top of the solution. And I want to close with a quote from one of our customers as Amazon.com, someone who built a third-party subscription. And they said that Amazon subscription boxes is their fastest growing channel. What we're able to do is empower the whole industry to reach their customers more authentically. It's just been a really powerful journey. Thank you so much for your time. Thank you, Rudy, for the introduction. I really appreciate this opportunity to talk to you about how we're able to use AWS serverless on Amazon.com.